Hey everybody, hope you're doing well. Today I want to talk to you about repeated measures one-way ANOVA. So this is an ANOVA that is slightly different from the one that we had talked about before. Really the only difference is that whereas in chapter 10 we talked about an ANOVA that dealt with samples that were independent from one another, this is an ANOVA that looks at samples that are dependent. So let's look at what ANOVA is doing behind the scenes with both the one-way ANOVA and this repeated measures ANOVA. So remember that ANOVA stands for analysis of variance. So what it does is analyzes the variance in the scores and the dependent variable that you're measuring from your cases, your participants. So let's say we're doing a study looking at the effect of a drug on behavior. We have some participants who are given some sort of placebo. We have some participants who are given a low level of drug and some people who are given a high level of drug. We would expect that depending on the group that you're in, you're going to perform a little differently. You're going to behave differently, right? There's going to be variability based on the group that you've been assigned to. So if we're doing a one-way ANOVA where your cases are independent of one another, we would have 3 treatment conditions, participants in one treatment condition and not any of the other. And what we would see is that ANOVA is going to parse out that variability into 2 sources, into our between groups variability, and again that's the variability due to the treatment that you're in, whether you get the placebo, the low dose or the high dose. And then it's also going to look at the variation that occurs just due to random factors, individual differences, that sort of thing. So in a regular one-way ANOVA, it's parsing it out into what I always refer to as our signal and our noise. In the repeated measures ANOVA that we're going to talk about today, it does the same thing, but it goes a little further. So we have our total variability in our scores. We're parsing it out based on the group that you've been measured under. And we also look at individual variation. But in that error, we're going to parse that out even further. So we can look at the individual contribution of variability due to individual differences, and then due to what we call residual, and that's just random error. So this is behind the scene how mathematically ANOVA is approaching the 2 statistics. Conceptually, the difference is that in the between groups one-way ANOVA, we are looking at independent samples, and in the repeated measures ANOVA, we're looking at paired samples or related samples. So you can kind of think of this one-way ANOVA as an extension of an independent t-test, and this repeated measures ANOVA as an extension of a paired t-test or a related t-test. So let's go ahead and look at the example that we're going to work on. The question that we're going to ask is behavior therapy and effective treatment for ADHD. So the idea in this example is that we have a therapist who's interested in looking at whether behavioral therapy can reduce distractibility in children who have ADHD. And so the idea is that this therapist has access to a population of children who has ADHD. They select 4 kids who have ADHD, and they measure them at 3 different time points, the same children 3 different times. First at pre-treatment, so this is their baseline level of distractibility. Then at post-treatment, so this is following 3 months of behavioral intervention with this therapist. And then again at follow-up, and this is after their behavioral intervention, but 6 months following that. So the idea is, does behavioral intervention, number 1, work? And number 2, is it effective long-term? So the data look like this. We have our 4 participants, and we have the mean and standard deviation for each participant at baseline, post-treatment, and follow-up. And what we can see is that the mean scores decrease at post-treatment. They rebound a little bit at follow-up. So the question is whether there are significant differences between these groups. And if we put this into a figure, this is what we're kind of looking at. Now we know that we can't just look at means alone. We see some sort of relationship here, but we know that this could be due to the independent variable, which is the time really of measurement, and it could be 2 other factors. So in order to determine whether it truly is the independent variable, we need to do some sort of analysis. So in the next video, I'm going to talk to you about the analysis. We're going to go through the 6 steps of hypothesis testing and interpret the results from there. So if you've got any questions, just let me know. Don't ever hesitate to reach out at asikorsky@tamet.edu. You guys take care. Bye-bye.